All right, section 4.4 is going to be dealing with factoring quadratics. Again, of course, quadratics is what we've been dealing with this whole time. But this is learning the process of what they call factoring. And you've done factoring before, and I'm actually not going to tell you or teach you any new methods on factoring than what you've already been taught before, but just you all need a refresher, of course. Okay, so the first process of factoring that we're going to look at is what they refer to as factoring out the GCF, which stands for greatest common factor, meaning that we're going to look and see what do our terms have in common. So the first example that I've given you here, we have 32x squared minus 16. So I need you to think of what these two terms have in common. Now, first of all, they don't have x's in common because I only have x's in the first term. I don't have any in the second. But I do have a number or a factor that's in common. First thing that might pop to your head possibly, might be like 4 or 8. But those are not the largest factor that they have in common. That's what you've always got to make sure you look for, is what is the largest that they have in common. In this case, that's going to be 16. So we're going to factor 16 from each term. Now, as far as just dealing with the number portion of it, you just simply figure out how many times will 16 go into 32, which would be 2 times. Now, you'll still have the x squared there that'll just come down. Nothing's going to change about that. Okay, bring down your minus sign, and then same thing with the next term. 16 will go into 16 one time. So you do have to make sure that you do put that 1 in there. So this would be your greatest common factor. And if you notice, when you look at your two terms you've got now, there's nothing left that they have in common. Okay, the second one that we're going to look at. Okay, now as far as just the number portion of it, we have a 7 and a 21. So 7 would be the factor that they have in common. But now this time I've got x's in both terms, but the most that I'm going to have in common is just going to be an x to the first power, meaning just 1x. So this term has 2 x's, this term has 1x, so the most they have in common would just be 1. So that means it would just be x to the first power. All right, so 7 will go into 7 one time. You have 2 x's, you're factoring 1 out, which means you have 1 left. Now, the 1 wouldn't have to be written in this case. You do have an understood 1 in front of the x, but if you've already written it down, then just leave it. Bring down your minus sign. 7 will go into 21 3 times. This term only has 1 x, and you're factoring it out front, which means there's not going to be any x's left here. So, like I said, that's just a quick little refresher there on GCF that you've had to do several times before. That's going to be a step that we're going to incorporate with some other things in just a minute. Okay, now what we're going to do is concentrate on factoring trinomials. And if you remember, a trinomial means that it has 3 terms, because that's where the tri comes from. Now, when you factor, just to kind of make these two notes make a little more sense to you, like if I were to give you this trinomial, and don't even bother writing this down, I'm just making something up here, but this would be an example of a trinomial that has 3 terms. So when you go to factor a trinomial, you start out by putting down 2 sets of parentheses, and there will be a process that we're going to go through to, of course, figure out what's got to be in there. Now, these 2 notes that you're seeing actually have to do with what sign, like a plus or a minus, do I need to put in each one of these. All right, so the first one states if the last term is positive, then you will have like signs in each parentheses. And that's actually the situation that I have right here. When I say the last term, I would mean, like on this example, this plus 3. So if I'm going to have like signs, that means I either have to have both pluses in here, or it could be that I have both minuses, okay? But each set of parentheses would have to have the same sign. Now, if your last term were negative, so let me just make up another one here. So let's say that I'll just change this to a minus 3. So if this were a minus 3, that's what it means by the last term being negative. then when we go to do our two sets of parentheses, then we're going to have different signs. It may be that this one needs to be plus and this one needs to be minus, or it could be reversed and this one needs to be minus and this one needs to be plus. But you'll have, one of each sign. So that's just going to help us to do the figuring that we've got to do on these problems. All right, the first trinomials that we're going to look at, these will actually be the easier ones, and because these are going to be easier, and that's because the number that you're going to have in front of your x squared is just going to be an understood positive 1, and that's what this statement right here is telling you, because the number in front of x squared is usually referred to as a, number in front of x is usually referred to as b, and your constant is c. So these examples will all have a positive 1 in front, and that's always the easier type of trinomials to factor. All right, so the first one that we're going to look at, we have 1x squared plus 7x plus 10. So again, I'm going to go ahead, set up my two sets of parentheses. Now, the first term that you have in this case is the x squared. So you've got to put something here and here that multiply to give you x squared. Well, there's only one option, and that's to have an x times an x, because x times x is x squared. Okay, so now what we're going to do is figure out, well, what do I need to put here and here that's going to multiply to give me the 10? So the first two slots multiply to give you this. The last two slots multiply to give you the 10. And of course, the 7 is going to come in here in just a minute. Now, there's a couple of different ways that you can multiply and get 10. Of course, that's 1 times 10 and 2 times 5. But if we're trying to come up with a 7, actually the way you're going to come up with the number in the middle is through adding. So you got to multiply to get the last one, add to get the middle one. So that would actually need to be the 2 and the 5. Now, it doesn't matter which one you put in which spot. And it doesn't matter because these two here are the same. Okay, now, go back to the two rules. Remember, I told you if this last term is positive, that means I have to have like signs down here. Well, what I'm going to need is actually both pluses, because you would have to have a positive 5 times a positive 2 to get the positive 10, but then you would need to add a positive 5 and a positive 2 in order to get your positive 7. So I know I've got to have like signs, but if I'd gone with both minuses, if I add a negative 5 and a negative 2, that means my middle term would need to be negative 7, and it's not. It's a positive 7. So this would be considered the factor form of this trinomial. Now, you've done this before, and if you remember, this is actually just the reverse of what's referred to as your FOIL method. Remember, you could multiply your answer back out. Remember, you multiply the first numbers together, the outer numbers, the inner numbers, the last numbers. In other words, both terms here had to be multiplied times both terms here. Combine like terms and you'll get your problem back. Like I said, this is just the reverse of your FOIL. All right, next example. Okay, start with your two sets of parentheses. And again, we don't have a choice here with the first part of each parentheses, because that has to multiply to give you the x squared, so that's going to have to be x times x. Now, there's only one way to multiply and get 2, and that's going to be 1 times 2. So I don't have an option there. Again, it doesn't matter which one you put in which spot for right now. It will a little bit later, but it doesn't right now because those two are the same. Okay, now I still have a last term here being positive, which means the signs that I use have to be the same. But in order to get a negative 3 this time, I would actually need both minus signs. Okay, so again, you got to multiply them to get the last one. So a negative 2 times a negative 1 gives you the positive 2. You got to add them to get the one that's in the middle. So a negative 2 plus a negative 1 will give you your negative 3 that you need in the middle. Okay, next one. Now, this one's actually a little bit tricky if you're not paying attention to the rule about your signs, and certain combination of numbers can be a little tricky sometimes. Okay, so let's start with our two sets of parentheses. Again, first term is x squared, so that's going to have to be x times x. Now, the different ways to multiply and get 6, I would have, of course, 1 times 6, and I also have 2 times 3. Now, in picking which pair, you're trying to get a -5 in the middle, and you actually can use a 1 and a 6 to get a -5, but you can also use a 2 and a 3 to get a -5, adjusting what needs to be positive, what needs to be negative. So before you actually even know which pair of numbers you need to use this time, you're going to have to go ahead and think about what your signs have to be. Now, I'm switching over to the other one now, in which your last term is negative, which means I have to have different signs down here, okay? Now, if I were to put different signs, and this is just, kind of like what you can think in your head if you're good with doing things in your head, or you can just use a simple calculator to help you with this. But like, if I were to put different signs on 2 and 3, like to try to get a -5, here's what I mean. Like I could go with a -2 and a 3, a +3, but when I add, I end up with a +1. Well, see, that's not giving me that -5. Okay, well, if I switch it and make the 2 positive and the 3 negative and then add, I get a -1. Okay, so see, using a 2 and a 3 with different signs, I know I have to have different signs, that is not going to give me my -5. Actually, what I'm going to have here is the 1 and the 6. But what you're going to need is a -6 and a +1, okay? So you got to multiply, so a -6 times a +1 will give you the -6. Now add them. So if you have a -6 and you have a +1 and you add, see, that does give you that -5 that you're needing in the middle, okay? So like all this that I'm doing is just kind of like what you can do in your head, or like I said, just use a calculator and, start adding and seeing what you get. Okay, one more of these. And changing it up just a little bit. Of course, the big difference that you're going to see with this example is that we have a -1 in front of our x squared. What you're going to want to do is actually make this so that it's a positive x squared. So all that you're going to need to do is factor out a -1. Okay, now when you factor out a -1, all that's going to do is cause your signs to change. So this is going to change to a positive x squared, a -3x, and a -40. Okay? Now, by taking out that -1, see, now my x squared is positive, and this will factor the same way that those other ones, like through the same process as the other ones did. The -1 is part of your answer, so go ahead and bring it down. Do your two sets of parentheses, so x squared is going to be x times x. Now with 40, we've got several options here. Of course, we've got 1 times 40, you've got 2 times 20, 4 times 10, 5 times 8. And I do believe that's all the choices we have that will multiply and give us the 40. But the likely pair that I need to use in order to get a 3 in the middle is probably going to be this 5 and 8. So I'm going to go ahead and put in those two numbers. Okay, since this is a -40, that will just tell me my signs down here need to be different. So I need 1 plus sign, 1 minus sign. But in order to get a -3 in the middle, like I'm using, don't go back and look at your signs here because you've changed them to be this. So in order to get a -3 in the middle, I need a -8 and a +5. Because if I were to add a -8 and a +5, I will get my -3, okay? So we're going to look at some more trinomials, but all of these are a lot easier to figure out than the ones we're going to do in just a minute, because we've always, on each one of these, always just had a +1 in front of the x squared.